Hello, it's CP Fundamentals again, and another CSES problem, which is chessboard and queens. So let's take a look at the problem statement, and then we will start brainstorming the solution. Okay, first, our task is to place 8 queens on a chessboard so that no two queens are attacking each other. As an additional challenge, each square is either free or reserved, and you can only place queens on the free squares. And however, the reserved squares do not prevent queens from attacking each others. And how many possible ways are there to place the queens? Alright. And the input had 8 lines. Each of them had 8 characters. Okay, so this did it just input the chessboard and tell us whether a square is free or reserved by the dot and this and the star. So we only have to print one integer, which is the number of ways that can place the queens. So when we read the output, we know that we must count the number of ways to put the queens on every possible positions on the chessboard, which will lead us to a technique or an algorithm, which are recursion. A recursive approach will definitely give us all of the possible answer, because they have to go through all of the positions on the board, which is kind of similar to the brute force algorithm, right? And because we have to place queens, and queens attacking each other by through rows or columns or the diagonals, right? And the diagonals here, I'm telling you, is both the diagon from the top left corner to the bottom right corner, and also the top right corner to the bottom left corner. Okay, and yeah, we can change the state of the board using the bool data type, which give us true if the square is free from any attack from other queens, or the other square is reserved or being attacked. And combine them all together will give us the number of ways to place 8 queens on the chessboard. Okay, I think I'm going to start with the solution. I'm going to input the chessboard using character data type, and we have bool row 10, d1 20, and d2 also 20. We input the chessboard first, and okay, so Oh, and also the answer equals 0 here. Okay, what else do we need? What else do we need? All right. Okay. Solve from 0. So we're gonna start with the first column, and by looping through all of the row, then go through all of the columns, we can check whether the queen is free or reserved or being attacked or not by identify the state of the square. Okay, void solve int c. If we reach to the limit of the if we place all the queens on a squares, we can increase our answer variable by 1 and also end the recursive loop there. Row 0. If so the diagonals that start at the top left corner to the bottom right corner is gonna be D1, and their indexes are row plus columns, and this second diagonal is gonna be R minus C plus 7, because R minus C because the diagonals from the top right corner to the bottom left corner can be a negative number, so we must add 7 here. So that will make all of the indexes a positive number. So the row true equals true, D1 R plus C equals true, D2 C plus 7 equal true, and then we make a recursion on the next column, and after that we have to change all of the position on the row, the two diagonals, because they are being placed a queen there. Okay, let's try the sample test case. Okay, yeah, I think this is gonna be the efficient solution for the chessboard and queens problem. Okay, let's submit it. Alright, and that is the solution for this problem, and thank you for watching this video. and you can leave a like and a subscribe if you find this video and also other video as well useful. Okay, thank you very much. Bye for now.